the opportunity you have to be in class today. I'm going to teach part of the lesson today. I probably will teach two-part lessons so that you guys have an idea. So you can do part of it, go to work on the homework, then next day you work part of it. That way it's not too much on one night, and I want you to be able to get it, and I'm in no rush to try to get it all done. All right? So let's review kind of what we've talked about in this chapter so far. We're talking about arcs, we're talking about chords, diameters, radiuses. This section is going to talk about sectors and segments. Sectors and segments. Okay? A sector of a circle is the region bound by two radiuses and the arc. So if I have a circle, two radiuses, an arc, this is a sector. So what is a sector? It's actually area. Okay? And I'm not sure that you can see real well, so I'll try again. You see that marker? All right. So sector is area. I'll turn off the lights in the front, or we can dim them. See if that helps. Or I don't know if that helps or this will help. See how it looks. The lighting, can you see pretty clearly? Yeah, I guess that's pretty good. Kind of just a reflection. Maybe you should try with the big lights. That. How about that? All right. Well, I mean, nothing's perfect, but you see the circle, you see the arc. All right. The segment, which is made up of two radiuses and a segment. All right. Looks like you can see that pretty clearly. All right. So a segment of a circle is different. A sector is area. Segment is the region bound by a chord and its intersected arc. So in other words, a segment is arc length. So perimeter. So those are important things. Okay? So you have sector, area, segment, arc length, or perimeter. All right? So here's the key. What makes up arc length? Well, we got to figure out what our equation is and what we're going to use to solve. So we are looking for, this distance of a circle. So first off, let's review. If I have a whole circle, from here all the way around, what is that? If I was going to walk it, it would be the perimeter. What is that? Another way to say perimeter, it's circumference. Circumference. So this is circumference. So what is the equation for circumference? Let's see. Jasmine, please answer that. I hope you're not absent. I won't know because I won't be here. But Jasmine, if you're there, please answer the question. Circumference is 2 pi r. So circumference is 2 pi r. Circumference, 2 pi r. Okay, and that's important. Okay, so what we're looking at is now thinking about, so let's think about this. If I want a part of a circle and I'm looking for the arc length, or the distance I walk on the circle, if the whole circle is 2 pi r, what would be the simple distance, the small distance that I walk? Well, that's important. You need a certain shape. That is theta over 360. Now, theta is, by the way, the central angle and what that angle is. Okay? So whatever the arc is in terms of theta, or what it will be in terms here. So what we're talking about is we have theta, which is the angle or the arc measure, but we need the length, the actual perimeter or the length of it, the actual walking distance, not just the arc measure, okay? There's a difference between measure and length. So what you're going to do is you're going to use theta over 360. The theta is like an x or a variable, and that variable is what you're going to find when you see the circle. So you have the circle, which is theta, over 360. Now, that's the fraction, by the way. This is the fraction of the circle here. So, what's the whole circle all the way around? Jacob? See, I even call you wrong on a video. Jacob, 2 pi r. So what is the fraction of the circumference? You would put them together. Theta over 360, 2 pi r. Put all over top of 1. If you all over it. And so, now I can solve these problems. So now that you have the equation, this is the equation for what? The segment. The segment is theta over 360 times 2 pi r. So, let's do a couple problems. All right? I hope you can see. We'll use our equation. Once again, every time you do a problem, you should show your equation. That helps. So, here's our circle. Can you see our circle? See, class? There you go. So now, let's say it's 45. Our radius is 5. I want to look for our segment. What equation are we going to use? Theta 2 pi r over 360. So what is our radius, Travis? Radius on this problem is the number 5. Good. All right, so we're going to plug that in. What's our theta, Mariah? Oh, you're absent. I'm sorry. Oh, no, you're not absent. You're good. So, Mariah, what are they? Good. 45. So the theta is 45 because that's the angle. Times 2 times pi. And Travis, you said 5. Good. Over 360. So now, I need to do some elimination. 2 goes into 360. How many times? 180. Good. 5 goes into 180. How many times? Anybody? Nobody? Oh, good job, Katie. 36. So now, 45 goes into 36. Well, what is a common denominator, a common multiple in those? 9.